Okay, so domain and range, basically domain, we're talking about all we care about on domain. Domain has to do with X. I think of Nintendo DX. You guys are probably too young to know what a DS is. And then you look at this. That's your input. That's your first number. Okay, I try and do anything that'll help me remember what does D stand for, what does domain deal with. It deals with X, and when you think about the X axis, it deals with left to right. So domain, I would like to know when we do it in interval notation, it's either going to be a parenthesis or a bracket, whether we include it or not, but it's going to be the far left-hand point that this graph goes over to. And then you put comma, and then it'll be the far right-hand point. Okay, you want to go all the way to the left, and it could be either parenthesis or bracket, depending on interval notation, if you include it or not. So basically for domain, we're looking left to right. For range, I have no fancy-dancy way to remember that, except I remember domain is X, so range has got to be the other letter. That's the Y. Okay, it goes from the lowest to the highest. And what I mean by that is I want to look at the graph. Okay, whatever the graph is, here's the graph. You're like, wow, that's a weird graph, Miss Sweat. Okay, so what? The domain, where's the graph start? Well, it starts here, and it goes to here. So for domain, I'll make it orange. I'm not going to write any numbers because I didn't label any numbers, but that would be domain. Okay, now for range, I'll go ahead and take a different color. The range is looking for low to high. Well, where's the lowest point? Looks like maybe there. That would be the lowest, and up here would be the highest. That would be my range. Okay, so when we look at a graph, we're trying to find those values. Well, sometimes the graphs have arrows on them, meaning, let me just have something like this. I'll put a solid circle there and say that line just keeps going. There's nothing else to that graph. Okay, so if I'm looking for domain, I'll just say this is at -2 there. All right, domain, I'm looking for the input, the X, Nintendo DX, so I need the farthest left-hand point. So I'm going to go all the way out here on X and say I'm going to go all the way out to -infinity. Do you think I'm going to see that graph somewhere? I think if I look up, since this graph has an arrow, it's going to continue to infinity and beyond. So I know for sure if I go all the way out here to the left and I look up, I'm going to see that graph. So I know it's going to start at -infinity. Now I'm looking for the far right-hand point for domain. Well, obviously it stops right here at -2. And I get to include that -2. There's my domain. Okay, now range talks about lowest to highest. Well, what's the lowest point for this graph? Obviously right here. I didn't mark it, but let's go ahead and let's just say it's 1, 2. Let's say it starts at 3. Okay, so I get to include that 3, solid circle. Now I need to go all the way up and say, where does that graph stop? Does it stop? No, I'm going to contend that it does not. That arrow, that line's going to keep going and going and going and going and going and going like the Energizer Bunny. Doesn't stop. So I know if I go all the way up here to infinity that, yes, that graph will exist over there somewhere. In fact, if I go all the way up there, I'll probably get to some point where it's -infinity, +infinity. But don't care about that. What I care about is what's the lowest point that this graph exists at and what's the highest point. The highest point in this case will be infinity. I think it's harder to wrap your mind around ones that continue on and on and on and on. On your homeworks, I'll look at number 2. Well, actually, I'll look at the first 3. Number 1, domain. We're talking about X, left and right. Okay, well, the farthest left this graph exists at is -3. But notice how it's not at -2. It's not at -1. In fact, there's no graph in between these two. That's where you have to use the little squigglies and say, okay, X can only be, it's only defined at -3 and at 2. X is only graphed right here and here.
The one that's not connected, it's a squiggly line?
Yes. So like on number 5, you'd have a squiggly line. It's just saying here are the values that X can equal. X can only equal those 2 values. That's the only time you use the squiggly. And it's very rare. Usually you're going to have domain looking like some interval. It's not often that X is only just 2 different numbers. Now for the range, what's the lowest point? Well, see, because this graph is going downhill, okay, I know eventually I can go all the way down to -infinity and that graph is going to be there. I can also go up to +infinity. So for my range, it's interval notation. I can start at -infinity up to +infinity. Is it a function? Well, vertical line test, obviously, no. It's not a function because I hit right here. 2 is being a player. 2 is being partners with 2, with 3, with 4, with 5, with 6, all the way up to infinity. 2 is being really not a nice person. I mean, it's one thing to be a player and just have 2 girlfriends, but this dude or girl or whoever, if it was a girl, you'd have a name for her. For a guy, they call him a player. A girl, they call him not a nice name, but it's not a function. You don't want to be like that girl or this girl. Oh my God. I know, guys, that's like your goal in life. Just saying. It should not be. All right, number 2, domain. Domain talks about X, Nintendo DX. IN is the input, the first number, the X. Far left starts here. It starts at -5. Goes all the way over to, and it stops right here, +5. I get to include the +5 because of the solid circle. Okay, for range, I need the lowest point. Well, the lowest point is here. And some of you guys, well, do I know if I include it or not? Well, this one's not included, but this one is. As long as one of them includes it, you include it. So I get to include -2, and it looks like it goes up to +2. Include. Is it a function? Absolutely. Vertical line test, nowhere is X being a player. I mean, it might be a weird looking graph, but I don't hit 2 points. So this is, yes, it's a function. Okay, and last but not least, number 3. I know kids struggle more with this one, but I think it's easy. If you've got an arrow and an arrow on both ends, it's all real numbers, all real numbers. But you'll start to realize that. If I go all the way out here and say, does that graph exist? It does. It's way the heck down there because this graph is going to keep going down and down and down and down to the left. Eventually, it's going to get all the way over there. Eventually. But think about infinity or negative infinity. It's massive. Okay, it's the biggest number or littlest number in the whole wide world. Okay, so when I'm talking about domain, yes, it goes from negative infinity all the way to, and the reason it goes positive infinity is because this one's going to go uphill and keep going and keep going. That arrow tells us it's going to keep going and 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 going. Range, what's my lowest point? Some of you want to stop right here. No, this graph keeps going downhill. Eventually, I'm going to reach all the way down to where y is negative infinity. And then I'm also going to go all the way up to the stars, up to heaven, positive infinity. Is it a function? Yes, it's a function. Vertical line test. I don't hit that graph in any more than one place. It's a function. The only time it's not a function is where X is trying to be a player.